Thank you for joining the Ones Changing the World, India's first future tech meets sustainability podcast. And today, I'm delighted and honored to have with me Mr. Abhishek Upperwal. He's a data scientist by profession with expertise in blockchain and smart cities. He's the CEO at Soket Labs, working on ethical artificial general intelligence and are building foundational language models for 22 Indian languages. Their research focuses on the ethics of AGI, including alignment, safety, transparency, fairness, collaboration, and global cooperation. His vision is to advance the field of AI that can ultimately contribute to a solution for social issues. He has been engaged with the Smart Cities mission and co-led the Mobility Data Space project at the Ministry of Housing and Urban Affairs, and also co-led the Wastewater Intelligence Network Program at the National Institute of Urban Affairs. So Abhishek, really appreciate you taking time and being part of the podcast. You started as a decentralized data exchange for smart cities and then pivoted to an AI research firm. Share your works in the space of the smart cities and how you envision AI is going to transform urban governance in India.
Okay, to begin with, Adi, first of all, thanks for having me on your podcast. Really excited to be here. And to answer your question, actually it started almost in 2019. And back then, the core research work that I was doing was around peer-to-peer networks. And that was mostly inspired by what was happening in the blockchain space. It was booming and people were building a lot of peer-to-peer applications, and most of these applications were on top of one or the other blockchain network, right? So I took inspiration from that particular bit and I started thinking what can be done around the data side of things. So for example, right now, the major problem around data is that most of the data sets that we have is quite sensitive, right? So pooling that data in at a centralized place is literally exposing that particular data to a lot of attack vectors. And a better approach and even a scalable approach to distributing data and sharing data would be to actually decentralize the entire network of data distribution. And that was a core idea and the vision that I had back then. And I started exploring on how can that be done leveraging peer-to-peer network. So the core idea is very simple, that instead of we pooling in data at a centralized repo, you can just take an example of how data.gov.in basically works right now. It's a decentralized repo where all the ministries and different departments actually pool in data, but that's not a scalable approach. So instead of doing that, why can't every city can take ownership of their own data? And now we can actually connect all these cities through a peer-to-peer network, and essentially these will be distributed system protocols that will be built on top of the existing TCP/IP layer. And we can then do amazing things on top of this particular network. So these things could be, say, for example, doing data discovery. A person may say like a developer like me can actually join the network, which is a peer-to-peer network, and broadcast packets, which are discovery packets, and be like, okay, I need the ATCS or adaptive traffic control systems data for n number of cities, and the system automatically will be able to identify which all cities have an ATCS system and what are the kind of data standards that they are following. Will let me know about that particular bit, and then I can even do a data pricing discovery that, okay, X smart city has it, how much can I buy it for from X smart city, and then ultimately a data monetization would happen on a side chain, and then ultimately end up with a data exchange using the same peer-to-peer network. So the work that I essentially did or that we were doing at my startup was to actually create all these fundamental protocols. So you can just imagine these protocols being very similar to how TCP/IP works. We were actually building on top of TCP/IP and even UDP, because UDP is pretty amazing when it comes to peer-to-peer networking. And we were building these meta-level protocols on top of these layers which already exist to do all these things like data discovery, doing monetary transactions, and then ultimately doing data exchange. So to test out the idea, and again, you would have seen that the primary use case that we were targeting was smart cities. And just to give your audience some sort of context around it, so we have close to more than 100 smart cities right now. And all these more than 100 smart cities, how do they actually manage their data is through this integrated command and control center, which is sort of like a hub in the center. So it's basically a hub and a spoke model where hub sits at the center and Then you have various IoT-based devices, which are these either data coming from smart roads, smart traffic signals, smart whatever like are being deployed in the smart cities. And the ICCC actually at the city level pulls in all the data, and ICCC is the management system or the heart of the entire city's operation system. So we were directly connecting to these ICCCs and then creating this peer-to-peer network of these ICCCs in different cities. So to explore, to network, I actually joined the Ministry of Housing and Urban Affairs in 2019 itself. I was part of the Smart Cities program, which was being run by the Ministry of Housing and Urban Affairs under or with collaboration with National Institute of Urban Affairs. It's a pseudo government body under MoUA itself. And I got the opportunity to work with multiple smart cities over there and do like implement this particular project even in Faridabad Smart City. So we're working very closely with Faridabad Smart City, helping them out in with their data management and standard. We created a lot of data standardization protocol, which is again very much needed of. Say, for example, if 10 smart cities are relaying information about real-time traffic signals, when that signal goes from red to green, green to red, you will need some sort of standard to actually transmit the data. So we actually work with experts to actually create multiple data standards to do these transactions.
Superb. It sounds very, very interesting, though it sounds extremely far-fetched. The reason, because we live in a siloed world, everything is going inward rather than going outward. I thought that we live in an extremely hyper-connected world. And my assumption also was that, maybe we would all be sharing data, but I don't see anybody doing that. Some of the big companies, you call it, the name says OpenAI, but all their data is siloed. So how do you go to a world like this? Because it sounds really cool. You mentioned about 100 cities, sharing data. How does this even happen? Because, our governments, even in a country, states function in an extremely siloed manner. Each states have different parties and, things like that. And all of those data is siloed. How do we break from this centralized approach to a decentralized approach where the opportunities are going to be humongous if we, share a data? But I don't see anybody doing that. Even in the space of AI, at this point in time, almost all the companies, DeepMind acquired by Google, OpenAI, Inflection AI, acquired by Microsoft, Anthropic acquired by Amazon. How do we, even not just the smart city, even the AI, how do we kind of decentralize it? Do you have any intuition around that?
So that's quite interesting, and I too believe that I think decentralization of AI is very important because it will also enable literally everybody to utilize AI in its true manner. Right now, what's happening is that I think you and I are privileged enough to have access to a $20 chat GPT, and through that we are able to do some amazing stuff. But imagine $20 is a lot, right? Especially for the Indian market. And majority of the people who can't even afford it. And even if, say, for example, we start giving free of cost chat GPT API, say, for example, government has some scheme around it, I don't think majority of the people will be able to utilize it because we don't have access to electricity in the remotest parts, and then internet is a big problem, right? And there is a dependency of constant internet because these systems are so big that they need these dedicated GPUs to be executed. So I believe that decentralization in AI would happen when, and it's already happening. I think we are the next wave in AI is around decentralization and making these models really affordable and even scalable. And that is what we have seen even with, say, for example, Apple doing some amazing stuff and Google doing it in terms of building not large language models, but instead people focusing on small language models. And why these small language models are pretty amazing is because they are so small, they are highly energy efficient. And then not just energy efficient, you can actually deploy these models on native devices. Say, for example, a model running on my laptop or my phone device and things like that. So I think we are moving towards that particular deployment where models are getting smaller. We are using distillation techniques to actually do it. And there will be a time where these smaller models will natively be available in all our devices. And that is where I think the power of decentralized AI and access to everybody would come in ultimately. So that said on AI bit, Definitely, I think going back to the idea around smart cities and government and data sharing stuff, it is pretty tough to actually convince somebody to open up the data. I would have before the like joining the ministry and working very closely with them, I would have expected that it's only the private entity who would close up the data because it's natural to them. Like they want to preserve their IP and do something very close with their data, but governments are open by default, right? They are meant to be transparent, and by default they are meant to share the data, but it's actually not the case at all. Like one of the things that you will find, like if you are looking very closely at the government, is that every ministry works like an organization, as an independent organization to some extent. And because it is acting as an independent organization, people who are managing these ministries feel responsible for the data that they actually own. So just to take an example, say health data set, which is owned by, say, Ministry of Health. Now all the health data, even transferring that data or like utilization of that particular data under urban setting or by the Ministry of Housing and Urban Affairs is actually quite tricky. We tried doing that like in one of the project when we were doing this wastewater intelligence system one. So it was related to both urban and the healthcare. This was during the COVID time. And we tried so much to actually get some data out of the health ministry. And not like it was not me individually. It was a ministry who was trying to get the data set. And even then it was so difficult. So I think what we have done is that from the government, instead of making data open by default, we have actually made data closed by default. And then we have to justify on why certain data sets needs to be open. And that's absolutely an incorrect approach. That should not be opening. It should be open by default. And then you justify why you should close certain data sets because of maybe security reasons or whatever. But that should not be majority. That should be, say, 10% or 15% of the data set. Because maximum data set that the government has no sensitivity associated to it. It's not personalized data. Literally, it's data set which is like, say, for example, your traffic signaling emitting some data sets, which I don't know, even if it gets leaked or something, what can be done? Like you can't hack the system. It's just inbound data that I can just utilize to see how my traffic things are happening, right? So that I think that has to come from within the government. I think there are initiatives to actually streamline some of these things. One of the fantastic initiative, the Ministry of Housing and Urban Affairs, that I would point out is this IUDX project. It's called India Urban Data Exchange. It's actually anchored by ISC Bangalore. The entire development work is happening in ISC. And again, the core idea is very similar to what we were working with the ministry. It's a decentralized data exchange itself, where nodes will be created at every smart city, and then you can connect it through some protocols that these people have been building. But again, I have worked very closely with the IUDX team. It's the same challenge. Like you go to any smart city, they are like, okay, now we need to figure out which data set we will open, and we will scrutinize the data set first, and then we will let you know. And most of the cities are not comfortable doing that because I think it's not in their culture, right? Like the officers who are sitting at the top, they are afraid. They're like, what if something wrong happened with the data? I will be answerable. So unless they have very good incentive to actually do it, they won't be doing it.
The entire conversation of data is wrong. I mean, you mentioned about the health ministry owning the health data set. How does the health ministry own the data set when it's an individual's data? It's been given. So where does that conversation go? I mean, the conversation should be that from these big tech companies to everybody is exploiting the user's data. That should be I think there should be more clarity about that it's not a company's data, it's an individual's data. The company or the government is holding the individual data. I think that conversation needs to be more open so that people are aware. The whole problem is that, the common people are always exploited, always manipulated because we do not care, because we are so caught up in our daily lives of making that, whatever, or a work or a business work or education work, and we don't really know how these big tech and these governments are constantly the banking system is constantly manipulating us. So I think there should be more education around that, and I think that would be the right approach, because the data is not owned by the health ministry; it's an individual's data. Can you explain Soket Labs? What are you doing in some of your works?
Absolutely. And I totally agree on what you said. I just want to point out one small aspect. I think this will change when I think we have a full-fledged data privacy law, or or I would say multiple laws around data for an individual, personalized, non-personalized, things like that. But I think before this particular regime, it's primarily, I think, all these departments look at it, like for example, say municipality, whenever they are collecting your personalized data around housing and whatever, I think they are the custodian of the data. That is how I think they think about it. But then what they forget is that if they have to utilize this data, or if they are passing it on to somebody, they are just a custodian. They are not the owner. So they forget to take permission from us to before doing that particular bit, because there is no law around it. So once we have these laws in place, I think things will streamline, and much more power will actually come to the individuals to have a say in how their data is being utilized. I actually, after this idea of decentralized data exchange, almost 1.5 year back, when the craze around GPT was happening, what was happening with the data exchange idea was then again the same problem, that the data sets are definitely available, but getting access to these data sets and making them available openly is a major challenge. And our dependency was mostly on the government side. Like we were hoping that the government would be open and willing to actually open up some of these data sets, but it was not the case. And the period to actually convince them was way much longer. And we were like, no, this is not working. I think we need to work on some other aspect. And by that time, the boom around GPT and all was happening. And that was a fantastic opportunity for me and some of the folks from ISC to actually think about how we can contribute. So before going to that particular segment, just a bit about me. My specialization basically lies in high performance computing and distributed systems. And I've done my master's in data science from ISC Bangalore. So almost for 8 to 10 years, I have been involved in AI research, around doing research around computer vision, around distributed systems, and scaling all these algorithms to thousands of CPUs and GPUs, things like that. So you can just see that HPC right now is actually at the center of AI boom. Because to train all these large scale models, you essentially have to utilize an HPC system. That is why, like, companies like Meta, Amazon, they are building like these big supercomputers, and that everybody is pooling in GPUs, and they are like, I want to build the best supercomputer across like whatever is available around the world. That gave us like a fantastic opportunity to like actually work in the GenAI space, because me and some of my folks who have worked in NLP, we were like, if not us, then who would actually do it from India? Because we have that kind of skill set, we know how these systems work. So let's just give it an attempt. So the initial idea started that we don't want to work just with English. I think pretty much everybody in the Western world is now, like at that particular time, was also focused around English. So we were like, okay, let's just solve for something that has certain meaning related to India. And India obviously being a bigger market, and there is variety in terms of languages that we speak and dialects that we have. So India has its own challenges, right? And nobody was focusing on Indian languages at that particular point. So like, okay, let's just build for India. And the starting point for entering into GenAI is by default a language model. And the reason behind that is that for centuries, most of the knowledge that we have is actually in the written content. So it's not spoken, it's not videos, it's not images, it's just text. It's purely text. So it's absolutely natural to actually take this particular text and to train a model around it, so that all the knowledge infusion actually happens through on the language layer. And then you actually build modalities around it. And that is how even OpenAI or any other company who is working on state of the art right now has actually done it. They started with a language model, and then around that, a lot of modalities were actually built. So we started by looking at, okay, how can we actually train a foundation model, but using Indian languages. Our initial plan was to support all 22 different languages, but then we started going deeper inside, looking at the computation cost and things like that. And then we were like, okay, let's not go to 22 immediately. We don't even have that kind of data set. Let's just start small, and then eventually like incrementally keep on building on top of it. So we were working on 6 Indian languages. We trained a tokenizer, which is still like the best tokenizer that is available out there for Indian languages. And ultimately, we decided that we don't have that much compute and money to actually train for all 6 Indian languages. There were a huge amount of data as well. So we were like, okay, let's just do it for 3 Indian languages for the time being. And we started working on Hindi, Bangla, and Gujarati. These were the three Indian languages apart from English that we picked. And we started training our model. We cleaned a lot of data sets. Even then, the quantity and the quality of the data set was not that amazing. So the primary problem with Indian LLM or building an Indian LLM is actually availability of data. So you would have guessed that most of the companies who are working on LLM right now are actually scrapping the internet to capture the data. But what's happening if you start scrapping Indian language content? Most of these content would come from news media websites. So only these websites are like publishing and generating the content. But then that does not give us a lot of variety, right? Like we will be missing out on so much things and so many things. And then there is also biases associated with news organizations. So if you train on a biased corpus of data, your model will ultimately be super biased. And then you have to do a lot of effort to actually align it properly to remove all these biasness. So another effort that we did was we actually took 12 million articles in Wikipedia that was primarily in English, and we used an open source model to actually translate all these 12 million articles to 6 Indian languages. And it was a huge corpus. And why Wikipedia? Because Wikipedia, to certain extent, is factually aligned. There is really amazing content that is available on Wikipedia. Could be biased to certain extent because it's open data, definitely. But the quality of the data set was pretty amazing in terms of language and how people have formulated it and things like that, and even the factual information that is available in Wikipedia. So after the translation, we did a lot of data mixing, tried out a lot of models from smaller to bigger, and ultimately the outcome of this entire effort was the first open source model that is coming out of India, a multilingual open source model. We are calling it Pragna, and it's a 1.25 billion parameter model trained on 4 Indian languages. It has seen more than 300 billion tokens, and we call it a foundation model. Why? Because we expect people to build on top of it. So it's a foundation, it's a generalized model, but then you can create specialists out of it, or you can even bring your own data and then do fine tuning. But the model is actually not trained from scratch. So the initialization of the weights, we have not done it randomly. What we have done is, because again there was constraint around compute, we actually utilize an open model, which is TinyLlama model, again a relatively smaller model, which is fantastic in English. But it does absolutely, it was garbage when it comes to Hindi, Bangla, and Gujarati, all these Indian languages. So we took it primarily for its English knowledge, and then we applied a lot of techniques to do transfer learning on top of it. So the weight initialization was done with TinyLlama, and then we did a lot of transfer learning, did continual pre-training for Indian languages, and then ultimately Pragna was actually trained by seeing all the data set or the data that we essentially have. So that was the story behind how things evolved, and it took us almost like an year to actually figure out a lot of stuff. And one of the challenges, not it's not just data. Another challenge was that to train such a model, you essentially require a lot of moving bits and pieces, like especially in the code segment. You need a full-fledged like a code base to clean up your data, do all these pre-processing, post-processing, translation pipelines you need to build. And then ultimately, when we are going for training bit, even training these models is absolutely non-trivial because there are various techniques to actually do it. So you have to shard these models, figure out how many GPUs you will be utilizing, shard your data set, ultimately do some sort of hyperparametric tuning around it. Okay, what's working, what's not working. And then again, foundational model building is not a one-shot problem. Basically, it's a tree sort of thing where you start from one bit and then you start you do a lot of experiments, and you pick like certain experiments from those set of experiments, and then you start doing a continuation on top of them. So it's like multiple iterations you need to do. Certain things break, you might have to go back to an existing checkpoint, and then your entire effort is wasted. So you need to continue from that particular checkpoint. So it's a lot of hit and trial, looking at how the model is behaving. Is it aligned, not aligned, things like that.
Right, right. So Abhishek, I mean, kudos to you and your team for building Pragna-1B and your partnership with Google Cloud. Yes, I think you pointed out to so many challenges. Right now, I think because AI is in such an hype cycle, I mean, India, all the I mean, most of the startups are wrapper AIs. I mean, there's hardly anybody who's actually building foundation models. So kudos to you for doing this. I was reading an article of yours which was on AIM, on the challenges of building AI in India, and you also gave the actual comparison between a Western startup and and the funding ecosystem over there compared to India's ecosystem over here. So maybe you could address that the challenges and also highlight the government and the ecosystem support. Because I remember I was interviewing Deepak Garg in 2019. He's the director of Leading India AI and was part of Bennett Institute. I was also interviewing in 2019 Shailesh Kumar, the head of AI at Geo, and I was asking them, like, who are the researchers, who are the companies in India who are even looking at, AGI, and their response was dismal. They said, "Can none." In 2019, none. And then Sam Altman, I think back in 23, came and spoke. And then suddenly all the investors, all the government suddenly woke up and was like, "Oh, we don't have an LLM and we can build better LLMs and this." But the truth is, nobody wants to loosen their purse when it comes to deep tech, startups, because, the ROI horizon is later. So would love to understand your view on AI's ecosystem and the challenges of building a foundation models in India, and why we don't have any startup who's building LLMs in the lines of maybe OpenAI or the others.
Sure, sure. So I'll address the funding, I would say, difference when it comes to the Western world and India, and it's huge. So like even like what we call wrapper startups in US, the seed funding typically starts from 10 to 15 million USD. Even if you are like just using one of the APIs, definitely it has to be something useful for sure. But obviously integrating an AI and then API and then building on top of it, it's relatively easy as compared to building something foundation or even doing a fine tuning and then capturing your own data. So a 10 to 15 million for a wrapper startup. And when it comes to India, the average check size across the industry at the seed stage is approximately somewhere around 2 to 3 million USD, and maybe sometimes even less than that. And for people who are building foundational models, it's actually literally nothing. So, for example, for us, I did some estimate around how much money will we actually take to actually build a 7 billion model if you are building it from scratch. That money or in just compute comes to be around 2 million USD. And again, as I said, it's not a one-shot problem. It's basically an iterative thing. You lose out on a lot of progress. You have to go back, do a lot of tweaking around the data. And that is why it's 2 million. Like if you do a one-shot thing, definitely the cost will be less. But foundation model building would involve a lot of research, especially if you are doing it for Indian languages, right? Like English is pretty much, data sets are available, everything is available. You just need to start the process and most of the things will be done. But that's not the case for Indian languages. It's quite different. So that difference definitely exists, and that is also like one of the problem for us in terms of how fast we can move. It's not about solving the problem. We will solve the problem, but it might take us more time because of the funding crunch. I'm talking generally about India because of the funding crunch as compared to a US, say for example, a startup who can actually invest a lot more into resources, compute, and then move very, very fast. So just to give you an example, like typically what happens is that when we are doing any sort of model building, we have two options. Either take less number of GPUs and do training for longer duration, or second option would be take more number of GPUs but do training for a shorter period of time. Say for example, maybe a week or 7 days, you can just train a 7 billion parameter model somewhere around that. So, but again, for a longer duration, maybe the cost would be not that much because you are dedicatedly taking resources for a longer period, and that to like small number of resources. But for bust sort of workload, where you require, say, for example, a cluster of 128 GPUs, but maybe for a week, you will have to pay on demand because these reservations typically start for a month or 6 months or for a year. That is how these companies operate. But a shorter duration burst, you have to pay on demand, and on demand is definitely more expensive. So that definitely, if I look at the costing bit, this second option is not an option for me. Like for example, when we are training Pragna, it's a very small model, it's just a 1 billion parameter model, and that to 300 billion tokens is literally nothing. Llama 3 right now is trained on 15 trillion. and the older version Llama 2 was trained on I think 3 trillion or 5 trillion tokens, somewhere around that. So a 300 billion token training is literally nothing. But because of the constraint around the compute, we essentially have to go for a longer duration. It actually took us 2 months to train the model, and you could have done it in like 3 4 days. Now, just imagine if we could have done it in 3 4 days, we could have done multiple iterations if we had that kind of funds, and then our research trajectory is much more. I can build all these models and figure out like different aspects around how these things are working by doing different experimentation and then just taking one of these experiment and maturing it to a certain stage. And that is how typically it's done in the Western world. That is how OpenAI is able to like move so quickly, because even at the scale that they are operating, they are typically working on multiple iterations of these models and then taking the best one and then releasing it out in production and people then ultimately utilizing it. So that is essentially needed. And there is a challenge around it. So, for example, like how Gen AI is actually like different from traditional machine learning or general AI is that Gen AI, we don't know a lot. It's a sort of like a black box. I can create an architecture. I can train that particular architecture. I understand how, say, for example, optimization is working and the knowledge is being infused in the backward past. But once the model is trained, I don't know a lot about how the model is actually behaving. So that's another research field which is called explainability in Gen AI, where you go inside, probe the model, identify which neurons, what is it doing. A lot of research work has been done, but still it's not figured out. Traditional ML, we at least knew some of these stuff. Like it was more heuristic driven, where if I have to do natural language understanding, I will do a word to it first. I'll make these embeddings which are very close to, say, king or a queen. I'll understand the gender and things like that, and then I'll infuse it into a system which will work. And so some explainability existed. With Gen AI, nothing of that sort, and these models are huge. So that is why, like, what people typically do is because explainability does not exist, only experimentation can work. So I'll start doing these hyperparametric tuning, do different experiments, and then see, given a set of data set, given 10 different architectures, which particular architecture works best for me. And that is how you basically take the field forward and do some research and also build product out of it. So that was a challenge. And coming to the Indian ecosystem and how they have been supportive. So what I've seen in Indian VCs, started talking to a lot of Indian VCs almost like in, I think, 7 to 8 months back. Right now, we are actually in our seed stage round. We have already raised an FNF and you can also call it an angel one. Actually, I've seen a drastic change in VCs right now. 8 months back, the story was that people they were like foundational. No, 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 not absolutely not. We don't know when we'll get our returns, and maybe it is left for people like Microsoft and OpenAI who have these deep pockets to actually build foundation technologies. And we will just rely on them, and we will fund these startups who are utilizing the API of a very good model which exists, and we know that it's performing very well on certain aspects. But right now, I think the trend has changed. What people are understanding is that Gen AI inherently has to be experimental and has to be research oriented. The reason is that I build a, say, a rapper startup today. I can get disrupted by some of the open, like some of these bigger players in just a couple of weeks. That is how fast Gen AI is actually evolving right now. So you would have seen Search GPT is out, OpenAI is bang on disrupting Google and then Perplexity as well. And now Perplexity is asking that, okay, how can we do things differently? So if OpenAI is able to do some amazing work, I don't know what will happen to Perplexity, to be very frank. And if they also have to evolve. So most probably they might even go ahead and start designing their own models, at least to handle some of the aspect to create that particular niche that maybe by default through OpenAI they would not be able to get. So I think that particular knowledge and understanding is now getting like VCs are able to understand that particular bit. And because of that, I think there is some trend that is seen that even VCs who are investing in Gen AI are telling the Gen AI startup that, okay, work on some unique USP. Don't just utilize an existing API and build something on top of it. Either create some very novel workflows which are very different from just utilizing an API. That is also like one of the ways. Like, for example, when you create agents, you might have to utilize 2 to 3 different models. So you might be utilizing OpenAI for one thing, maybe say Llama, and you fine tuned it to do some certain actions that you want the model to perform. So even novel workflows work better. That is also like a new thing now. And going further, I think even investing in foundational technology, especially from India related or India point of view, is also something that VCs are pretty much looking at. So I spoke to like a couple of VCs, big VCs. They are absolutely like, I was so happy talking to them. They were like, yes, we have to be research first. That is absolutely fundamental when it comes to Gen AI. If you are not doing any research, and by research, I don't mean that I start doing research right now and after 5, 6 years I'll build a product. That does not happen in software engineering. In software engineering, research is typically a very short period of time. I can create an algorithm in 6 months, deploy it, and then get the fruits of that particular algorithm in just a very small period of time. That is how Gen AI is essentially it's evolving.
Right.
So, and this is the VC ecosystem. On the government side, to be very frank, again, I work with the government. I know this. Our government is actually more reactive instead of being proactive. And it is seen almost everywhere. Like something happened, and then they are like, "Oh, we had to do something, or we should have done something. Okay, now we will do it." So same thing happened with AI also, that when it was time to allocate money to boost certain startups to actually do certain work around AI, I think the government was not that much inclined to actually do that. When this Sam Altman thing happened, and now people started talking about it a lot, and then suddenly government is like, okay, we'll infuse money, and it's the conversation is only about infusing money. We still don't know what the SOPs are around that. We have no idea how that 10,000 crores will be invested. What are the modalities? I was at one of these events, India AI event, and interacted with some of the government folks. So they told me that now the empanelment process would start where they would actually, instead of like, the government is not creating infrastructure. What they are doing is that existing players who are in India who have these GPUs, cloud centers, and all, they will be empaneling them and taking their services. And either free of cost or at a subsidized pricing, they'll be providing these infrastructure to the startups who will be building whatever application they want. But that process is still in the pipeline. We don't know much about it. And then even the government is like, okay, we might have to wait another 8 months to an year to actually make these GPUs available to the startups. Now you can
Right.
just imagine that we need them right now. We
Exactly.
don't need them 1 year down the line. We need them right now if you have to match with what Western world is doing. So I think we are from government side of view, we are going in the right direction, but we are a little bit late. Could have done it a little bit earlier to support the startups. Yeah.
Right. Right. So Abhishek, I mean, I think the government, the VCs, the entire ecosystem, the education also needs to open up and understand we are in an exponential stage of human history. There was a
Yeah.
linear human history where we could have we had the privilege of, okay, wait and watch and let's see. And then, when somebody else shows us the proof of the pudding, that's when we jump into the bandwagon. That was the past. Today, I don't think we've got the privilege to do that because we are in exponential stage of human history where the tools, the technological tools are scaling, evolving exponentially. And the government and the VCs needs to understand that we are the largest populated country in the world. We
Mm.
have the largest youth population coming out of ITs, engineers, and software. No doubt, we are the leaders. But hardware, we have failed miserably. Whether it's the hardware stack of building computers to whether it's the quantum computing stack, which I think now India is waking up and understanding that instead of just the software, we need to also understand the hardware. Whether it's in the AR/VR sector, which I've been invested in since 2016, and I'm screaming at the top of my lungs that all tech stack is going to converge, and when they all converge, the utility is going to be humongous. So I hope that the governments, the education industry, the VCs, they wake up that right now is the time. They need to loosen up the purse, and we need to build foundational models, because wrapper AIs, I mean, like you said, maybe these multi-agent models, but building foundational models is so very imperative for India to move ahead in the time and be relevant now. With AI, like, I mean, every tech stack, it's, I mean, though it's in this hype cycle, there are these problems, because all these deep tech stack is like very cash intensive. There is the training cost, There is also the inference cost. Where is the money at? Where is the money at as a startup? How do you make an AI startup profitable? Because I mean, with OpenAI's, I mean, 100 million users, but I think they were mostly consumers, not the enterprise. How do you make money? Because I think, even recently I read this report by Goldman Sachs saying Gen AI, too much spend, too little benefit.
Right, it absolutely. So I too believe that I think it went to the scale that it is right now. Gen AI was mostly because of the consumer centric approach that OpenAI actually did. Imagine if OpenAI would have gone and be like, okay, we'll just open these models for businesses. First of all, they would have to make a very strong case that these things work, because at that particular point they are the pioneers in this particular technology. Nobody knew what ChatGPT could do, or such a system or a transformer architecture could actually do. They were the ones first to like bring it out in front of everyone. So a consumer centric approach was absolutely the best approach because we saw the scale and we saw the capabilities of these systems. But now what is happening is that I think in terms of making money or making GenAI sustainable, I think we are moving mostly towards the enterprise specific use cases. That is how the trend is. Definitely, I think consumer centric AI will play a major role, and these will be like end case or application leveraging Gen AI, and then people are actually benefiting out of it. But what will happen is that Gen AI will become a significant part of the existing workflows in the existing applications. So that is how it will happen. Say, for example, if I want to buy a policy, maybe a Gen AI agent will be able to help me better to actually plan out what my policy should be or where should I buy it from, depending on my age and things like that. So things will become more efficient, but in the existing workflow in the consumer centric. And I think very few apps will come which will be absolutely new, which never existed before. That will definitely happen. Now on the business side is where I think most of the money making would happen, because what's happening right now is that enterprises are looking at Gen AI and they're like, wow, this is a fantastic technology. This can actually solve n number of use cases for us, which traditional ML have never done, right? So take a case, say for example, like we are talking to a BFSI entity who is into education. So they what they do is that all these RBI guidelines that comes out, basically you need to educate like people in the remotest part of the country around what these guidelines are about. And that requires like you doing translation, you forming these question answers so that people understand that if a policy has changed, how should you deal with the customer now, depending on the new policy or whatever has changed. So they used to make all these questions and they used to do a lot of translations. But now they are looking at GenAI and they're like, oh, wow, this is a fantastic technology. We can actually automate a lot of stuff and even get very high quality content out of it. And this content can even be dynamic, because first earlier we were creating like this static content. Now we can create dynamic content based on even the personalization of the end user, right? On the fly, we can actually do it. So Gen AI has actually helped enterprises to be more efficient. That's the starting point. And then I think on top of efficiency comes the new usability part, which I personally feel that we are actually not, we have I think very few companies have started exploring. Most of the people, what they are doing is they're just working on the efficiency side. That, okay, take Gen AI, fit it into somewhere and then see, okay, if the efficiency is being improved. But new use cases or new capabilities of Gen AI, it's still evolving. And I think that is where we are moving when we say artificial general intelligence. Because today's model, what is happening is that they're fantastic at summarization, they're fantastic at translation. They can even reason to some extent. But when I go in depth and start reasoning to like very in depth about, say, mathematics or new physics that can be derived, or looking at string theory and maybe looking at quantum mechanics and figuring out how we can actually create a unified theory around it, these models fail. And that's the upper bound of these models as of now. So what I feel is that most of the typical use cases are being solved in the enterprises right now, and there is a lot of value around it. Definitely, the cost of these models has to come down to make it more feasible and affordable for everyone, and that is where we are moving right now. So, what has also happened, you would have seen, is there was a drastic improvement in the intelligence in the very beginning. Like OpenAI did some amazing work around building the best intelligent model that was available out there. right now, I think we are mostly working on the efficiency side of things. So intelligence, it's incrementally increasing, but not to the extent that it was doing or it was happening before. Right now, it is very, very incrementally small, but then we are working on the efficiency. And a new trend has been seen where people are even distilling smaller models out of bigger models. And these smaller models are not that capable as compared to bigger models, but it can satisfy your use case. But again, the important bit is, can these models be affordable and be more efficient? That is what we are doing right now. And in the near future, like once we have been able to like at least to some degree solve the efficiency bit, again, I think our focus will shift to, okay, now how can we actually improve the intelligence part of these models? Maybe new architectures would come. Maybe we'll start working on new sort of data sets. I think a new trend that we have seen is that when you have a bigger model, you can actually create data sets out of that particular distribution, utilize that particular data to train a smaller model. And the smaller model performance is way better as compared to you training it on raw data. So that is again a new trend that is now coming out for training all these smaller models that are out there. Yes.
Kudos to you and your team, and more power to you and your team to hang around and build these models more efficiently. So, because I'm sure, I mean, these business models are going to open up in the due course of time. And you rightfully pointed out, these LLMs are like become static at this point in time, though there are so many people who are working on various approaches, multi-agent models, SLMs, and so on and so forth, to kind of, juice it out more to becoming more efficient. And then there are these other group of people who know that we've come to a point where we are maybe seeing how you can turn these narrow AI into general purpose AI, what you spoke about, artificial general intelligence. Now, there are various camps who are building or working towards that for the longest time. Demis Hassabis from DeepMind has been working on from the longest time. His approach has been neuro-inspired AI, combining deep learning with reinforcement learning. There's Ilya Sutskever, who just moved out. And then there is Sam and even Andre Kapati are from the same camp, that they believe scaling LLMs will lead to AGI. Then there's Jan LeCun with JEPA model, the joint embedding predictive architecture. Believes that a self-supervised learning and building common sense into AI is the possible approach to building AGI. Then I per se have interviewed a few people who are working towards AI. One is Ben Kurtzel's company Singularity Net. I interviewed Janet Adams, who's the chief operating officer. Their approach is what you spoke about, decentralized approach, which is a blockchain-based AI network with neuro-symbolic AI learning. Then I interviewed Pei Wong, who's got NARS, which is, I think, the non-axiomatic reasoning system. And the focus is on creating AI systems that can operate with insufficient knowledge and resources. Then I've also interviewed Randall Coney, whose approach is whole brain emulation, emulating the entire human brain. And he believes that understanding the entire cognitive structure is the only way to building AGI. Who are the researchers here in India who are even thinking about AGI?
Right. That's a fascinating question, and I think the approach like that you spoke about that. I think one thing is for sure. I'll answer your question, but just to give you some context, scale has like it's been proven now through multiple work that people have done, that scale is one thing that can definitely lead us to AGI. That's for sure. But the bottleneck or the upper bound to scale is again the data, because the current models that existed or which we have already given it huge scale. Like GPT is 1.8 trillion tokens, right? And it has trained on the entire internet's corpus, plus maybe some proprietary data that OpenAI might have procured. So ideally, what has happened is that OpenAI, as of now, would have exhausted the upper bound on the data set. And definitely now the approach could be that maybe we show a couple of epochs of the same data to the model again and again. So instead of say 3 epochs, we can go up to 5 epochs, for example. But internet scale data is already exhausted. So even if we like scale up the models, say like a 20 trillion parameter model, I think the bottleneck would automatically hit on the data side of things. So scale has proven and maybe can give us AGI for sure. But I don't think it will really solve the problem, because if even if we scale, data upper bound would be hit at some particular point. So the next approach then could be, say for example, like at the fundamental level layer, what's happening is that because most of these models are attention based models, we are essentially trying to map the distribution of the data set that human beings have created onto a particular parameterized neural network. So basically, it's about distribution. Like if today magically I can just or I can just predict that okay, this will be the distribution, although the distribution would be way too complicated given the parameters in these models. If I can do that magically, I won't even need one bit of computation on that particular bit, right? So just to figure out that particular distribution is what we are doing around the scaling bit of these models and then showing it huge amount of data. So, but because we have a bottleneck in data, and this is also true for Indian languages, like one of the bottleneck that we are working on is that we don't even have internet scale data that English people had for Indian languages. So we to can't even think about it ki we can build a 1 trillion parameter model just for Indian languages. That's absolutely not possible. Another alternate could be figure out ways to actually fit that distribution in a more efficient manner in the architecture itself, given the data constraint that you have, right? So then maybe the scale factor would break. Then I would be like, fine, I will not look at the scale. I'll just figure out, say, something new within the architecture to actually map out the distribution, which can actually consume less data. And as you rightly said, people have been working around this particular concept. So now coming to your question, like who is talking about AGI? Frankly, not a lot of people are talking about AGI. I also feel that in the Indian context, because AGI is a very heavy word. Now, definitely it can excite a lot of people for sure, but India is a more business-centric, like people look at India as a more business-centric opportunity. Like talk about business, don't talk about these superficial ideas. Let the Western world do them and attempt them. हमें धंधे के बारे में बताओ, like talk about the business part of things and tell me how to make money. Don't tell me about AGI because I don't know whether AGI will make money for me or not. So I think people who are going and building businesses right now are too business centric, and that is why they are like, oh, let us just stick to the use case. Let us just solve for the use case and make money, a certain money out of it, and then we will see if we want to talk about AGI or not. But to be very frank, my thought process is not like that. I think we have to aim for that moonshot first, and then like once we have a trajectory towards it, let's just attempt it. If not the moonshot, at least we will reach somewhere in the middle, right? So you in the very beginning or somewhere in the middle, you said that India needs to have its own foundation model. It's actually not just about having a foundation model in India, because when you are building a foundation model, you also get a lot of expertise, right? The know-how of what breaks and what is being like attempted and what works is also like one of the knowledge that we Indians will be getting out of it. If I'm working in Microsoft, building their file model or some other model, the maximum knowledge that any public or it goes out in the public is through their research paper. And that is very restricted. They might not even be releasing like a lot of that information because that is proprietary. So the only way to obtain that information is, okay, fail, fine. If I fail, I'll know what things are not working, and maybe in the next iteration I can work and do things differently. So it's not just about having a foundation model in India. By building that foundation model in India, we are also capturing those nuances around what's failing and what's working, and that ultimately can be contributed towards any other domain as well, right? So maybe working in AI for defense, which is again a very very will I rely on Israel technology to actually give me AGI to build something for India? Even US won't do that. Like the AI and defense is something which is very very sovereign. Like India has to build its own AI and defense capabilities, for example, and that can only happen when people are working in AI and failing fast, figuring out how things are working and not working, and then ultimately contributing into other fields. So that is also like another aspect.
Abhishek, yeah, I really hope that India understands that research is the core. Look at Google. It's because of DeepMind they've built such fantastic models. And it started with research. It started with DeepMind. Look at Microsoft. It started with OpenAI, and OpenAI started with a moonshot of building AGI. That's how they got developed LLMs. When Google was the first company that figured out transformers, the underlying core architecture of LLMs. But it's OpenAI who leveraged that and build an LLM. And I think research is the core. I'm not undermining business. I mean, business is needed. But I think unless and until we don't have those moonshots, I don't think we're living in the privilege of the past. We are in 2024, and the way at things, the rate at technology is growing, there'll be a small developer sitting in a small obscure country which will be building technology such as AGI, nanotech, maybe virtual reality, which is indistinguishable from reality, and it'll all go to these small developers. So I believe that tech per se is becoming more decentralized. I don't think it's going to be the big companies developing these powerful tech stack. It's going to be the small companies with these really deep thinking researchers who break away from the just the financial models and find deeper meaning into solving a problem which will deeply impact humanity. I hope that we understand that. My last question to you: what are your thoughts on device AI? Because there have been so many companies which have been working on device AI. Human, which got shut down recently. There's Brilliant Labs, that Rabbit Inc., who are working on device AI, and then there is AR, VR, MR devices, which they are also trying to cram these LLMs onto the HMDs. I believe that the world is gonna go from carrying technology with your phone and your computer to wearing technology. We're going to a world which is IoT, where everything is going to be wearable. So, what's your thoughts on wearable AI? Your advice to startups and students here in India, and what's your moonshot, Socket AI Labs moonshot?
Before I jump to that particular question, just one bit around business side of things. Obviously, I'm running a startup. Business is absolutely important for us as well. So it's not like we don't emphasize on business, but the difference between being a business-centric organization and maybe doing research and then solving for businesses, that's the difference. Like either we can figure out, okay, businesses have these certain problems, then we look for solutions for these particular problems, and then we give it to the businesses, and that is how most of the companies earn money. And that is absolutely, like, that's the way absolutely things have should be done, and majority of the people are doing it. But then it also has to be like in reinforcement learning, we have two different paths. One is, okay, I know certain aspects, I'll just take that particular route, but then there is certain experimentation or a route which I don't know about. And when I go on that particular route, maybe I'll find a better solution to do certain things. And that is what I was talking about when I said research. So figuring out new stuff, and then looking at, okay, the GenAI can actually solve ample of problems that already existed, and then fitting it into this problem regime, and then figuring out the solution around it. So that is what the approach of a research-centric company would be, for example. Coming on the IoT base, it's absolutely exciting, to be very frank, because as I said, to make AI affordable and accessible to everybody, I think we have to put AI on small devices. Now, what I don't believe is that you need to build a specialized device to actually do that. That's the difference in what, like, most of these startups are doing. That what they are doing is they're not even building like on-device AI. They are utilizing an API of OpenAI. We have created like this hardware, and then utilizing the API of these particular like on these devices. So that's the problem over there. But I believe that, okay, quantize these models, make them smaller, make them more smarter, and then maybe just install it in your phone, install it in your laptop, like the devices that already exist. Now you can create a specialized device, say for example, for a specialized area, say for example, healthcare. Maybe you would require a speech-to-speech sort of agent, which is available at the bedside of a patient to do something very specific to healthcare for emergency purpose, for something else. Now, then there you require a specialized hardware device for sure. Then you cannot rely on a phone or anything else. Maybe you require a very high like energy efficiency, smaller devices with inbuilt LLM with some speech to speech support and things like that. So that makes sense. So if you are going into some specific niche area which require that particular device, absolutely. But on devices, most of it would first, I think, come on your phone. It has already like Galaxy has done it, Apple has done it very quickly. I think laptop AI embedded in laptops would start coming out. And it would be very similar to how you use chat GPT and all. Like at least some basic functionality would be available out of the box. And for some higher order stuff, maybe you have to again go to all these larger models. through some API connection and things like that. That is how I think it will evolve. So my again, my recommendation to startups who are working in AI and hardware spaces, I would definitely ask them that figure out that niche area where you have to build your own hardware, which makes sense. And on device, definitely explore it for sure, because even your cost would go down. Like for example, I'll give you a case where one of these very big TV manufacturers, we are talking to them right now, and they have a clear cut problem. They're like, we are selling our TV at 20,000 rupees. How can we expect a $20 subscription after selling a TV to the user for utilizing OpenAI APIs? That does not make sense at all, right? So to enable like any sort of GenAI specific use cases, the AI has to be embedded in these devices, and only then these devices will be useful in utilizing GenAI. It won't happen on the cloud. That's not the solution.
Last question to you. Your advice to students possibly and your roadmap, Soket AI Labs roadmap.
Oh, to students who are getting into GenAI, absolutely do it. I would highly recommend it. And how I look at it is maybe let me just split it into different layers of how GenAI is, and then you can figure it out. Where do you fit in better? So I'll start from the top. You have this application layer where essentially what you are doing is that it's very similar to how you do software engineering, where maybe you have a black box system which gives you certain aspects through an API interaction. Just imagine OpenAI being a black box system, and then you are building applications on top of it. Very interesting things can actually happen. So this I think we have started abusing this term as wrapper startups and things like that. But even utilizing APIs, you can actually create amazing agentic workflows. So you can do innovation around that particular bit, but that's the application level. You are not going too much depth into GenAI, essentially utilizing an existing GenAI system to solve for a particular problem. Underneath that, you have systems where, say, for example, the model is not working for you. You might have to do some sort of prompting to the model, maybe have utilize some thought process, prompt the model in chain of thought sort of process. So that is where you would require at least the understanding of how Gen AI is being generated. So how these systems are trained is very important. So for example, if I need to understand how do I apply a prompt engineering, I would go ahead and look at the fine tuning data of that particular model, and understand for what particular task the model was trained on, or what's the kind of data that it was basically trained on, and what was the prompt that were given during the training phase. Because if I aligned like my prompts to the prompt that were given to the fine tuning phase, I think my output would be pretty amazing. So doing that at the prompt level, again, you would need to not go into the depth of how GenAI is being like generated and all, like how does it work, but at least understanding the generation bit of it, and then utilizing prompt engineering and getting the best output from the model. So that's the second level, I would say. And then again, that also goes and flows into the use case specific things, because you have to create prompts for your specific use case. Third level that I would say would be where you are working and you are like, prompt engineering is not working for us. The first level to didn't work for us. Then I would be like, okay, I have certain data sets for me, but then I might have to go and fine tune a model. I have an existing open model which I might have to fine tune, and that's the third level. That after the third and the fourth level is where you would actually go into the system side of things. Now you need to understand how the architecture of these models are. Should I tweak certain aspects around it? If I have to do fine tuning of the model, which particular layer should I target to do fine tuning, for example? Or what's the kind of data set, and how do I format that particular data set to do fine tuning? Again, this is more system specific and in depth about the model aspect itself. So if you are pretty excited and you are amazed about how these Gen AI systems work, definitely this is the layer that you should absolutely go into and start tweaking and figuring out stuff in this particular layer. This will help you take your model to the next level. Say, for example, Llama 3 might be failing for certain aspects. You can actually make it amazing by maybe say creating your own data sets and then fine tuning Llama for that particular niche specific use case, things like that. At the fourth level is where these foundational level things actually come in. There is a level below that, but that is more hardware specific. I won't be going into that particular bit. But the fourth level is where the foundation technology comes in. Say, for example, I have to create a model for the BFSI sector. Now, BFSI sector is very regulatory sector. Data is absolutely critical for me. I can't take a llama, I can't take any other model. Those things are not working for me, but I have sufficient data to actually train a small model that I can do. What I will do is I'll actually train a foundation model, but a small language model in that particular category, so that even the inference cost is less. And then I can have very high throughput on that particular model itself, and the performance can also be better than even GPT-4 if I have like good enough data to do it. But at this particular level, because even if it is a small language model, say a billion parameter model, you will have to utilize techniques like model sharding or model parallelism, pipeline parallelism. There are these techniques to actually train the model. How do you shard the model? How do you prepare your data sets? The complexity actually increases, and you might even have to figure out which particular architecture do you have to use, or run certain experiments around 3 to 4 different architectures to actually figure out which one actually works better for your specific use case. So again, if you are passionate about absolutely the core of Gen AI, this is the layer that you should be in. I would highly recommend. Karpati has been doing an amazing work in terms of how do you build like these foundation models from scratch, and go to his channel and watch all his videos. Do not even miss like a single minute of the video. That's for sure. You'll get something out of it, absolutely, for sure. Just touching upon like what's beneath the fourth layer, it's mostly about compilation, and after the compilation it's mostly about how these hardwares are working. So when it comes to compilation, a lot of work is actually happening on making your Gen AI abstract tree, or this the model architecture, even more efficient to be executed on specific hardwares. So for example, in PyTorch, when I create a architecture, it could be any architecture, say Llama or something, that ultimately has to be executed in forward backward pass in some specific hardware. Now this hardware could be A100, it could be H100, it could be even TPUs, or it could be some AMD's GPU, which is now coming up. So at the compiler level, what you are doing is that you are taking the same abstract tree, which is your model architecture, but then you are compiling it for different specific hardwares, and you are even optimizing it using different levels. So if you know about MLIR, it's a multiple level intermediate representation, which is a part of LLVM. So they do this level by level by level optimization, and then your GenAI code can actually be optimized not just for GPUs, even for CPUs, for example. So if you are into compiler, if you have done some advanced courses around it, definitely this is the stack. And not a lot of people actually talk about it, because most of the things are just above foundation and things like that. But a lot of work is also happening around it. And I would especially point it out, if you are in we Indians, we actually don't know this much about Indians. Indians have a major contribution when it comes to compiler building. We are pretty amazing at compilation, like all this LLMVM project, and all, if we see, majority of like many people, Indians are actually contributing into the project. So we have been doing extensive work around it. So this is definitely like something to learn, something to ponder upon and see if you want to contribute. And then it comes to the core hardware, where for example, like my field is in HPC, so my specialization lies in building very high efficient CUDA kernels, for example. So I will be, say for example, like this memory bandwidth is a major issue when it comes to the hardware. We don't have sufficient memory, and then if I do a lot of data transfer between my memories, I am taking a lot of time to do unnecessary work. I should be doing computation and not doing memory transfer from one memory to another. So over there, I can actually build much more efficient algorithms which are memory aware, which do not do a lot of data transfer and then invest a lot of time into computation. And that is what even I am doing in my startup, where we are looking at different aspects and components within GenAI stack, and then figuring out how each of them can be executed on the hardware, and we can run them way faster when it comes to the forward pass and the backward pass. So that's the last level of how our hardware is made. You can again go in depth and figure out making hardwares, and which are, say for example, just to do neural computation or doing tensor computation, but that is another field altogether. Yes,
Right.
and in terms of the roadmap of what Soket Labs is doing, I'll share an interesting idea. If somebody thinks that they can actually solve it, definitely reach out to me. It could be like an open challenge as well. Why not? So what we are doing is we are actually taking inspiration from neuroscience, and we have been like how neuroscience, our brain basically works is that language representation and knowledge representation are basically two different parts of the brain. So if I learn French today, my knowledge is retained, but I'll be able to converse in French with my friend, right? Very easily. Most of the facts are already retained. So, but that's not happening in the current architecture in attention mechanism. Essentially, what happens is that if I have to learn a new language or infuse language into the model, almost the entire data set I have to show to the model almost all the time for every new language, and that is absolutely inefficient. So what we are trying to do is we are actually trying to bifurcate the architecture into two different components, where one works around the language part and the other works around the knowledge part. Just to hint out on what we have been doing. So, for example, the language representation can actually be done using graph neural networks. That is something that is now coming up. So, you like utilizing all your dependencies within different languages, how these are evolved, taking a root language and then evolving it into subsequent languages can be represented beautifully using graph neural networks. So that is one part that we are exploring along with other things. And the knowledge aspect, I think the attention mechanism works amazingly well for the knowledge part, but we have to connect them through some latent space in the vector space. So again, a lot of experimentation has to be done. So that is like one path that we are taking, but there are multiple tracks also that we are doing right now. But quite interesting. I feel like GenAI is just the starting bit right now. I think it'll take humanity to the next level, and definitely you want to be at the center of it for sure.
Right, completely. Abhishek, thank you so much for taking time and being part of the podcast. I'm going to leave your email and your links behind so that people who accept the challenge of finding the link between the language and knowledge representation, I mean, can reach out to you. More power to you and your entire team at Soket Labs for building Pragna-1B. And I hope there is more researchers, more Indian developers who stand up and be counted, because yes, I think we're living in a momentous time. And I think almost all knowledge is out there open. And like you said, Kapati has got his channel. I mean, if you're building LLMs, you can, there is so much data out there. I think open source is the way to go forward, because, there are the biggest companies in the world who are still building closed source, and I think the only way to building technology, which is beneficial for everyone, is when it's decentralized. So more power to you and your team. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you later. Thank you. Thank you, Abhishek. Really appreciate this.
Thank you so much. Bye bye.
Thank you.